Hello everyone, let's continue with the Sean-Prasad pattern. And in this question, we are solving another linked list problem. We are given the head of two sorted lists, and we want to merge these two lists into one sorted list. And this list can be made by slicing together the nodes of the first two lists, and we want to return the head of the merged list. So just like we can see from this example one given, right? We have 1 2 4 here, and we have 1 2 3, and we want to merge them together to give us this sorted list. All right, let's give ourselves some room and jump right into the question. So we are given let's work with 1 2 3, and let's work with 1 2 4. Right, so we know that for any linked list problem where we want to manipulate the data, manipulate the content, the first thing we want to do is we want to traverse the list. And while traversing this list, we want to run a comparison, right? We want to run a comparison on both lists that we are given. While running a traversal here, we're going to compare these first numbers. We're going to start right at the beginning. These first numbers, are they equal? Are they greater? Which one is greater? Which one is smaller? And then whichever is smaller, we want to return that number, right? So I'm just going to return 1 here. 1 is smaller, but we still have 1 as an excess here. So 1 is still the next number in the loop to be compared. Let's assume that our basis of comparison is this first number, right? So we compare 1 that is still in the loop here with the second number in the first list. Since we've already returned this first item, we still have this one left. Now if we compare both together, we can obviously see that 1 is smaller than 2. So we're just going to go right ahead and return 1. Then this has already been sorted. Now we have 2 here, and we are moving to the next item in the second list, which is also 2. So we compare these two together, and we can see that, well, they are both equal, right? So we just pick one of the 2s, and since we started with the first item, we can just continue with that. So we return 2 here, right? We return 2, and then we have this 2 that is a leftover, and we compare it with the last item in the first list here. We compare 2 and 3, and obviously 2 is smaller, so we return 2. Then we compare 3 with the next item in the second list. 3 is smaller, we return 3. There is nothing to compare 4 to, right? So we just return 4. So basically that is how we are going to solve this problem. We are traversing this list, and we want to compare each element at every iteration. Now a question you might ask is, okay, but what is the condition for traversal, right? Are we traversing the first list here, or are we traversing the second list? Because we know that while traversing, we usually have a syntax like while current, where current represents the head of the list. But in this case, we're giving 2 lists, right? And so which of the head do we use to traverse? How do we go about this? Our first instinct, now let's give ourselves more room. Our first instinct might be to find the length of the longest list, right? Because it just makes sense. Let's imagine that this is 5 and this is 6. It makes sense to traverse using this one, since the length of this linked list is longer than the length of this first list. But we also can see that we don't have any way of knowing that the length of this second list is longer. If we traverse through the first list, the one with a shorter length, then we are going to lose access to this one, because basically when we are done traversing this current head, there is this 2 excess that we don't know what to do about it. So we know that if we are going to determine what we use for traversal, we have to find the length of the longest list. Now to find the length of the longest list, that means that we basically have to run a traversal through this one. Traversal just means loop. I keep assuming everyone knows. That means we have to run a traversal. We have to loop through both lists to find the longest. That's taking extra time complexity that we do not need. while that is going to work and is a good approach, that is not what we are going to be using. Instead, we are going to be using the condition of while true. And this is going to be an infinite loop. We know that if you run while true, true is always going to be true. So we're going to use a condition to stop and break out of our loop. So we don't have to first check which of the list is longer, as that is looping through both of them to find the longer list, and then looping again to traverse and merge them together. Another thing that we can also do now, that's two cases. The first one is getting the length of the list to loop through. The second one is using an infinite loop and finding a way to break out of it. And the third way basically is we can actually just pick a random list to traverse through. You can pick that you want to traverse through this list, and then just add a condition of when either of this list is done. I'm going to show you the code walkthrough. I'm just presenting you with ideas on how to approach this by yourself before you watch the code walkthrough. So yeah, we're just going to, there's a way that if we can just check after traversal, if we don't want to go through the hoop of finding the list with the longest length, then we can just pick one at random and then add an if condition later on that, okay, you know what, if one of these lists does not exist anymore, then let's just return if there are any items in the second list, right? Now it can also be this that doesn't exist anymore, and it's just going to work either ways, right? So we can just say that, let's say this is the current head, right? This is head 1, and we are looping while head 1, and once head 1 is done, we still have 5 and 6 pending. Right now we have 2, we have 3, we have 4, but we have 5 and 6 pending. We can just say that, okay, if head doesn't exist anymore and head 2 does, we can just append the elements of head 2 to head 1, and since they're already sorted, we know that we are going to be good and they're still going to be sorted. Now let's jump right into the code. Now let's code this off. By the way, if you're not yet subscribed, please do consider subscribing, and if you enjoyed this video, please consider giving it a thumbs up, as it helps the algorithm share this video with more people. All right, so let's go with the iterative solution first. And first we want to define a dummy node. So how this is going to work is that we are going to have a dummy head where we attach all of the numbers to, right? So let's say we have 0 as a dummy head, and while we are traversing, if we are comparing, then we can just start attaching, right, the smaller values to this dummy node. So tail, okay, we don't need to define tail really, and we can just say that while true, I did say we're going to use an infinite loop. While true, if list1 dot value is less or equal to list2 dot value, then we want to append, right? And we append by using dummy dot next equals to list1 because it's the smaller value. Else we just want to say that dummy dot next is equal to list2. By the way, we need to move the pointers of list1 and list2 so we're not stuck in any more infinite loop than this is already causing, right? And we can also move list2. But you might have noticed that this solution does not cover for if we add a problem of this nature. So let's say we have 1 2 3 and we have 1 2 3 4 and 5, right? At some point, list1 is not going to be less or equal to list2 because list1 exists no more, it stops at 3, but we still have 2 values of list1 that needs tending. So what do we do here? Now this is where the if condition I mentioned at the end of the conceptual overview comes through. We can just say that if not list1, like if list1 doesn't exist anymore, right, because at some point it's not going to exist anymore, then we want to append the values of list2, and this is also the point where we break out of this infinite loop by using break, because if list1 doesn't exist anymore, then we want to break out because there is nothing to compare. So this is where we break out of the loop. But in the case that it is actually list2 that doesn't exist, then we want to append list1, and let's just make this an elif statement says, since it's a chained if condition, right? And also we want to move our dummy, right? Want to move our dummy at every iteration. So let's run through our code quickly before we try to run this out. We are creating a dummy node while true. We're using an infinite loop. If list 1 doesn't exist anymore, then we know that the next item to be appended is list 2. And if it is list 2 that doesn't exist anymore, then we want to append list 1. If the value of list 1 is less than the value of list 2, then we want to append list 1, right? And we also want to increment list 1, want to move forward. Then if it is list 2 that doesn't exist, we want to append list 2, and we also want to make sure that after every condition we are moving list 2 forward, so it's not overwriting one another. And then we just want to return dummy.next, because know that the first value is going to be set to 0 as it is defined in this class. Now let's run this code and give it a spin. Okay, so we have a wrong answer here. Oh, and this is because we don't have the break pointer. We are not exiting this loop. So let's try to give this another spin. Okay, we are still having okay, let's try I want to see that problem. I have a theory for why this does not work, but I'm just going to be sure that I'm testing this out. Okay, so we're returning just 1. Oh, I see what is going on. So we are overwriting our dummy node. We have no reference, no pointer to this dummy node. So let's define something here. Let's create a new head, right? And then we are going to create a pointer to it. We're going to create a pointer to it. So dummy is going to be pointing to tail, and at the end we want to return tail actually, because tail is the one that has not been manipulated. Dummy is getting iterated, and this should work fine. Cool. Now let's submit this. And as we can see, this works okay. Let's solve it recursively, right? And for that I'm going to create the helper function. I'm going to call list 1 and list 2. I'm also going to be returning merge at the end of the code, right? I want to return list 1 and list 2. This return statement is to make it clear that we are going to be the argument we are passing in is the list 1 and list 2 here. So what's our base cases? Our base cases is that if there's no list 1, we want to return list 2, right? And if there is no list 2, we want to return list 1. These are our base cases. Now let's actually go back to solve. If list 1 value is less or equal to list 2 value, then we want to assign that. We want to run the function, the helper function again on the next value, right? Because that is how recursion works. We're just going deep and reducing the base cases, or reducing the possibilities until we strip everything down to the base case, and then it's kind of like climbs up from there, the call stack thing. So we want to call this merge, we want to call this function again on the next value, right, of list 1, and we also want to return L1. Else, that means list 2 is smaller, and we want to just do the same for list 2. L1, L2, the next, and we want to return list 2. So let's give it a spin. Cool, and try to submit this. Great, this works, and it's even more, is it more efficient now? Okay, I think it's more efficient than the iterative solution. All right, thank you so much for watching. I'll see you in the next. Hello everyone, here's Blossom from the future, discussing the time and space complexity, which I did not discussed earlier in the video. So the time complexity for both the iterative and the recursive solution is going to be O of m plus n, because we are looping through all of the values of the first list 1, let's represent it as m, and looping through all of the elements or values of list 2, which is also n. So that's O of m plus n. Now the space complexity for this iterative solution is O of n, right? Because we are using a dummy node to store it. But because the dummy node is only going to grow as large as the inputs from the two lists, it is negligible, and you'll see in some answer or cases where people are giving the result as constant space. But I rather just use extra space O of n, because we do use extra space. But if you do choose to give it a constant space, it still works, because the resulting output can only grow as large as the given input, which is sometimes negligible and sometimes cannot be, because it is as large as the input, right? So whichever works for you, or you could discuss it with whomever you are solving the problem with. And for the recursive solution, the time complexity is also O of m plus n, because we are traversing through list 1 and list 2 represented as m and n. They would both take a linear time operation, and we are bringing them together as m plus n. And the space complexity is definitely O of n, because we use recursion. It uses the call stack. All right, I hope this is helpful. See you in my next video. Bye.